In this video, we'll be looking at example 4 on page 218 of the Maths Handbook and Study Guide for grade 12. Example 4 reads, the points A, 5 and 2, B, 6 and minus 1 lie on the circumference of a circle. The center of the circle lies on the line y equals 2x minus 3. Now, before we dive into the question, something very important, not only for analytical geometry, but just in general for all questions. When they tell you that a point lies on a line, we normally have to write that point in terms of x only. So in this case, they've told us that C is the point x and y, and it lies on the line y equals 2x minus 3. So before we start, I just want to explain what I mean. If we have the line y equals 2x minus 3, and I tell you that, say, x equals 2 is a point on the line, then we can write y is equal to 2 times 2, which is 4, minus 3, which is minus 1. So I could write the point as 2 and minus 1. If I told you that the point x equals p lies on the line, then we could write the point, the y value, as 2 times p minus 3, which is 2p minus 3. So we could write that point as p and 2p minus 3. So in this case, they have told us that C is the point x and y. So my x value is x. So that means my y value is 2x minus 3. So I could rewrite point C as the point x and 2x minus 3. So if you know the equation of a line and a point lies on that line, you can always write it as the x value and the y value as the equation of the line. So let's have a look what they've asked us. They've said for us in question A, determine the coordinates of C, the circle center. So what we're going to use is the principle that the radius of a circle is always the same. So the length of AC and the length of CB are equal. So that's where we're going to start. We're going to use distance formula, and we're going to write AC squared equals BC squared. You could also write it as AC equals BC, but I don't want the square roots in the distance formula, so I'm squaring both sides to start with. Right, so our distance formula, I'm just going to remind you, is distance is equal to the square root of x2 minus x2 minus x1 all squared plus y2 minus y1 all squared. So if we look at AC, we're now going to write it as 5 minus x all squared plus 2 minus y all squared, and BC is going to be 6 minus x all squared plus y, which is minus 1, minus y all squared. I don't have to have the square root because I'm using it as d squared equals x2 minus x1 all squared plus y2 minus y1 all squared. All right, so now we have a slight problem. We're trying to solve for two variables with one equation, which is not possible. And that's where we write our point C as x and 2x minus 3. So what I'm going to do now is I'm going to change every y into 2x minus 3. The maths looks scary, but it's still basic algebra from grade 10. So now I'm going to rewrite that formula as 5 minus x all squared plus open bracket 2 minus 2x minus 3 all squared is equal to 6 minus x all squared plus minus 1 minus, I'm going to use a square bracket just because it looks nicer, 2x minus 3 all squared. And now it's just a simple matter of using algebra and multiplying out. So we're going to write 5 minus x all squared. That becomes 25. Don't forget your middle term. Multiply by 2, so it's minus 5x times 2 is minus 10x plus x squared plus, now before I multiply this bracket out, I want to simplify in the bracket. So it's going to become 2 minus 2x plus 3. 2 plus 3 is 5 minus 2x all squared equals 36. Don't forget your middle term, multiply and times by 2, so it's minus 6x minus 12x plus x squared, because we're squaring. And then again, I'm going to multiply out this bracket, so it's minus 2x plus 3, minus 1 plus 3 is 2 minus 2x, all squared. So this is going to become 25 minus 10x plus x squared plus 25 again, we square the 5, minus 20x, don't forget to multiply by 2, plus 4x squared equals 36 minus 12x plus x squared plus 4. 2 times minus 2 is minus 4 times 2 is minus 8x plus 4x squared. And now we're just going to add all our like terms together. So we have 25 plus 25 over here, which gives us 50. Then we have minus 10x minus 20x, which is minus 30x. And x squared plus 4x squared is 5x squared equals 2. Let's add our like terms here. We only have 36, so that is 36. And then minus 12x minus 8x is minus 20x. And then we have x squared plus 4x, which is plus 5x squared. And then you'll notice I accidentally left out that plus 4, so we actually don't have 36. We have 40. Now, we have the same like terms of 5x squared on both sides, so those will cancel. And what we're going to do now is bring all our x's to one side. So we have minus 30x minus 20x. Take the minus 20 over. We're going to have minus 30 plus 20 is minus 10x is equal to 40 minus 50 is minus 10. And therefore, x equals 1. So now we have the x coordinate of our circle center, and we have to find the y coordinate. So we've got here that x is equal to 1. Now that we have an x coordinate, remember that lies on the straight line y equals 2x minus 3. If we have an x, how do we find a y? We simply substitute it into the equation. So we're going to substitute x equals 1 into the equation of that line. So it's y equals 2x minus 3. And that gives us minus 1, 2 minus 3. So my circle center C is going to be x equals 1 and y equals minus 1. Right, let's move on to question B. And question B asks us to determine the equation of the circle. We know the circle center is x equals 1 and y equals minus 1, and it's always useful just to draw that in on your diagram so you have it there. And we know the equation of the circle is x minus a all squared plus y minus b all squared equals 2 r squared. So let's fill in our circle center. So the equation is going to be x minus 1 all squared plus y plus 1, remember always the opposite sign, all squared, is equal to r squared. So now again, there's two ways that we can find the equation of the circle. We just need the radius. So we can quite simply use distance formula to work out what r squared is. So r squared is equal to x minus 5 all squared. I'm using point A here for the distance formula. You could also use point B, plus y minus 2 all squared. But what is x and y? X is 1 and y is minus 1. So now all we have to do is punch that into our calculator. 1 minus 5 all squared plus minus 1 minus 2 all squared. And that is equal to 25. Remember, they asked us for the equation of the circle. We don't have to give the radius. So this becomes x minus 1 all squared plus y plus 1 all squared equals 25. The other way you could have done this, and I'm going to do it very quickly, just get a straight line, is we could have substituted a point A or B into this equation and solve for r squared. You'll see it actually turns out to be the same as the distance formula. So all we're going to do is I'm going to use point A, x equals 5, y equals to 2. So in my formula, it becomes 5 minus 1 all squared plus 2 plus 1 all squared equals r squared, and then r squared equals to 25. Either way is fine, whichever way you prefer. Let's look at example C now, where it asks us to determine the equation of the tangent which passes through point A. Just to make life a little bit easier, we've got the diagram drawn again. We know this point over here is 1 and minus 1. And they're asking us for the equation of the line, or the tangent, passing through point A. So the first step is to look at the gradient of the radius. So we know the gradient of our radius is y2 minus y1 all over x2 minus x1. So that's going to be 2 minus minus 1, so 2 plus 1, all over 5 minus 1, and that is equal to 3 over 4. And we know the radius is perpendicular to the tangent, so therefore my gradient of my tangent is equal to minus 4 over 3. So now we know the line here is y equals minus 4 over 3, x plus c, and all we have to do is solve for c. How do we do that? We substitute a point on the line. So it has to be point A. You can't substitute point B, and point B doesn't lie on that line, and you can't substitute the circle center, and the circle center also doesn't lie on that line. So our equation is y equals minus 4 over 3x plus c. Always tell the examiner what you're doing. You substitute in point A, which is 5 and 2, into the equation. So y is equal to 2, and that's minus 4 over 3 times by 5 plus c. So c is equal to 2 plus 4 over 3 times 5. I'm just taking that over to the other side, and I'm writing it as c equals. Don't get confused by the notation. And I'm going to plug that into my calculator. 2 plus 4 over 3 times by 5. And my y-intercept, or my c value, is then 26 over 3. And that asks you for the equation of the tangent. Don't forget to write it down. It becomes y equals mx plus c. My m is 4 over 3 plus c. In the next video, we'll be looking at example 5 on page 219 of the Maths Handbook and Study Guide for grade 12.